Okay, if I can go live about a half hour than what I scheduled. Um, just trying to, well, that's probably fine for all that. Yeah, I'm actually going through and doing adjustments to the studio as well. So I didn't comment it on the to my left in the back. I'm actually going to go through and put. I'm looking at moving um, my Net Fandy 7,000 back there, and that'll actually keep the place a little bit warmer. It's not too bad this morning. In fact, I was looking at how do I get out of the way of my camera views if I've got two overlapping camera views. But back in that void where my AS400 used to be, I've moved that to the house, and I've been working on the angles of the thin clients back here in the background. And you'll see even the one thin client I have active right now. Um, and if I get hold of the right mouse to where I'll be demonstrating these later on, and hopefully have a link up that I can use them for the terminal angles I'm doing, 5250 terminals. But I do have my token ring adapters down. I had to go retrieve some of them where I was working on them elsewhere, working with the clipboard. And I've got the heat gun here. I even pondered of going through and firing up the heat gun and pulling off some components to to go through and to look at a little bit closer, and also to send to Ken for him to get the some images of the dies, and in particular the code names that will be present on those chips. But we'll see what we can pull out here in just a moment. And okay, I'll get back on the internal webcam here, and I hope I won't have to eat in front of anybody. I heated up my breakfast a bit ago, and just a late start to the morning. Good morning, Jesse. But you will see me drink my coffee. In fact, I should have brought my veterans bottle. Would have matched my shirt, but coffee went in this one. Water goes in that other one. So I'm gonna drink a little bit of coffee to get my morning started as well. But yeah, it's I as I said, just a little bit late to start. Still catching up a little bit in my morning, and in fact, we'll go over just go briefly through some of the things. I don't want to necessarily relaunch Chrome to update. It gets nagging me. I'll do that after the stream. And I think I got a little bit of responses for my other display is doing that thing now where when it shifts focus or gets updated information, it blanks out for a moment. So that is really wonderful. Okay. And we'll prove I was getting I announced this on the Token-Ring group that I was going to do a live stream, and got a little bit of people looking that over. I of course used the thumbnail image of the Pine Grove Shrink on the YouTube thumbnail. So, and we may go through. Oh yeah, I don't know why this other screen. Well, I was just a little bit late for my stream this morning. Getting a comment of what is happening. I'm just getting settled in the studio this morning, going through and have things arranged. So I can start providing links is another thing I can do. I went through, and of course, last week I went through and showed Ken Sheriff's pages of him going through and the examination of these Token-Ring chips. In fact, the thumbnail image is from this page and of the Pine Grove Shrink. And I haven't quite gotten into I need to examine the earlier spyglass adapters. I'm trying to go through and get chip pinouts and get a little bit of layout of the adapters as it is. And okay. And then this is a spyglass. The 8-bit adapter uses the spyglass chip. I'm still having my my screen go through and okay. And let's get into the activity because I'm putting this into a Google Sheet. I'll share that as well for the pinout stuff. It's just a job in progress. Oh, the screen is just irritating. Okay. And I'm going to have my system catch up to me. Let me see how my system's doing here, because I am just seeing delays with what it wants to do. Okay, and I don't know why all this is all super big on my screen either. Okay, here's the link to the Google Sheet I'm composing together for the pinouts of the various Token-Ring. I don't even want to resize my Chrome window because it's got a relaunch to update button that's right over the top of that. I'm getting that. I'm showing that sheet as really large on my screen. It's even funny that, and it probably wouldn't be able to show it. In fact, let me go through. I'll drop my internal webcam. The on this thin client, I'm operating off the HP unit back here in the back, and this is kind of at the same time that Windows XP was coming out. This is Windows CE 5.0, and it has a terminal emulation program on it, an application, and I'm been busy setting that up on the different ones to access my AS400. But I went through, and of course I've got the web browser aspects working as well to that. It's kind of interesting that some of the pages at least load out there with these thin clients. But so as I say, for the spyglass, I was debating whether I could go through and even pull up some of the blog posts and things like that, or some of the newer pages on that thin client for this. But so let me see. I think I have a few. I wanted to have somewhere I've got the later chip as well. These are the Spyglass adapters, 8-bit adapters, like Ken has on that teardown page. This is exactly the same. And this is the well-known Spyglass variant, the most common one out there, that 63F7704. And we even went through and did a little bit of the study in this last week of the code at the bottom. I don't know if I discussed this last weekend, but it's got that one. And the interesting thing was Ken was able to trace IBM documentation to where, despite the bevel on the edge of this ASIC chip, pin 1 is actually down here in this lower corner. And in fact, let me go through. So there's the back side of it. And I have brought this up on prior times. I don't know if I'm better with the light or not. To taking down the intensity, maybe. Well, that takes up the intensity. Taking down the intensity. Okay. So that ring light is just right on. See, I talked about maybe in the past that SG in the center being the notion for Spyglass, the marking for Spyglass, and telling what chip was there. But pin 1 is marked by, and funnily enough, it's not on these solder pads. It's not a square pin like it typically is. I just happen to know that pin 1 is down in this corner, and so kind of resuming what I was talking about, can determine that that 1 at the start of this lower code means that the pin 1 being in the lower left of the package. And the next 2 digits, that 9331, that's 1993, and 33 is the 33rd week of the year. So this is built back in 1993, so 30 years ago for this this particular chip production, this batch that it was in. And the later codes on here may have a little bit to do with versioning or something else. I'm just not quite so sure on that, going through and coordinating. The this is actually a slightly, here's the other variant that has this. Should have one of the earlier Spyglass that the camcorder is just not picking up with that kind of the patina on that cover. But that's the 51F1439. And this, okay, so this would be, it has that leading 1 again for the pin 1 of the package, and that's 1990 and the 34th week. So this is almost 3 years before that that other adapter. And really the components have not changed otherwise, primarily just in that spyglass variant of the chip. This is still marked as spyglass internally, even though it's an kind of an older version. And you'll notice, of course, with these being comparable chips, that unique appearance of how the solder pads are on the PCB, and they're both marked as spyglass, but having that void of pins off to one corner a little bit more. And I've gone through all my spreadsheet if anybody's looked at it, and I have kind of the other tabs of a view from above. I don't have the spyglass stuff populated so much right now. Now, this is an even earlier adapter here, and these labels, I've tried to peel them to see the sizes of the ROMs and things like that when I was reading them. This goop, at least it's dry here. I did have the Mold 57 up on the bench, and it's left all this sticky goop on the table. I'll have to go through and pull out the isopropyl alcohol and go through and clean the bench and see if that will cut into that. But this is kind of a mid-level adapter, as it were. And I found it interesting that there were some components removed, and then they had the bodge wire stuff here. And then they had the ripple chip socket with circular pins, probably also the EEPROM sockets up here that these ROMs are in are probably also. No, they look like they have a standard wiper contact. That's funny that IBM put the socket with this with the center pins, not just the standard wiper contacts. And this is probably a socket that holds up longer over time, or is more of a prototype sort of fabrication that with the way that they have it. I don't know why they have those holes in the package, but you can see that those go down to contact pins. That may have been a way of verifying or something else that the socket was maybe fully seated. I don't know. That's really strange for having these the holes in the packaging. But with the chips removed, I was thinking that this was actually, and I need to come across a few more of these, because this is the there's the 02F8442 as the IBM part number, and this is from 1989 and the 6th week of 1989. So another more than a year earlier from the other adapter as well. And there's even an earlier what I think is a spyglass variant that I need to get actually more of, and that's the 89X9991 package. Now on here, this IBM 14, that is the production plant that IBM had for this chip. And I think we were figuring out that 54 or 52 was the, we'll see the 9314 on some of these. Okay, so that's got the 14. And what we're saying for this one has the 14. Okay. And this one has the 9352. And we're figuring out, I think the 52 is Rochester, and 93 is the Canadian, the Bromont plant in Canada. And those are the chip production areas. They went through and they did a 4-digit or two separate 2-digit plant numbers together like that for the 9352. And so I'll go through and I'll give the it's my camcorder that much out of focus. I wasn't looking at things. I wasn't looking at comments during all that time either. Oh, okay. So the IBM plant codes, and most of these are compiled from systems, the serial numbers. The serial numbers of, get back on the screen here, the serial numbers of the IBM PS2s as well as the other series, they have a leading 2 digits and a dash, and those 2 leading digits are the plant code of where that unit was assembled and in the IBM system. And so it doesn't necessarily cover chips, the aspect of chips, all that much, or that's a separate detail. But the Burlington, Vermont, and Bromont, Canada are the locations where a lot of the chips were done. Those are chip production areas, plants. Okay, there's the plant codes I've just put in chat. And so, 3, and why did I go through and close that? Okay. And you can look through that chart. 93 is the Bromont, Canada. And then the 14 is Burlington, Vermont. 52 should be, it's listed as East Fishkill, New York, but Rochester, New York for that 52. And there's a lot of chips that were made at the Rochester location as well. So that, as I said, that one, I have an 8-bit adapter, and the reason I don't even have an example up is that I need to go through and get more of those to be able to have enough to pull one off the board and send it to Ken. And the other thing I want to do is, this is a later LAN streamer. And I mean, this is even the original plastic packaging from IBM. They had a area for all the manual and things like that, and diskettes that they included with these. But this is another adapter. I have a few of these. I want to kind of check to make sure that I have enough spares of these, because this is the, I knew it'd get me at the time that I'd go through and talk about it. But this 50G 8180 is the Huntingdale ASIC, and it is a little bit different. It's a later package as well. Doesn't really have the same pin outline. It's actually got 4 less pins than the other ASICs for handling the Token-Ring aspect. And then you can see with the, if I can get it to, okay, get the light just right. And it still has that one in that, the leading one in that lower sequence, 93 for 1993 and 09. And like I say, that's why I think that later point in the series is some sort of versioning, because all the 001s and some of the characters there. It's got that 9314 for the plant codes. But I want to go through and pull off one of these Huntingdale chips to send to Ken as well. And I've been doing that through just having my just a standard kind of heat gun. This is my Milwaukee heat gun that I've been using to go through and just go through and pull chips. Maybe at the end of this, well, I have enough samples of the pine growth shrink. I wanted to even go through and pull a chip and even pull the cover here, even though Ken has kind of covered those. I wanted to see just what it'd be, how it'd come to doing that on a live stream, just to kind of see. So I don't know, maybe if we have some spare time, I'll do that to where I can plug in the heat gun. That'll certainly warm up a little bit more of the place. So I have my clipboard and my multimeter that I've been going through, and people can kind of see the work that I go through and have been doing for the chip outline. I just go through for continuity on my multimeter and go through and step through on the chip pins, ground and positive of the VCC voltage of 5 volts is pretty easy to determine on the chips a lot of the time, and that's why that's so marked on the spreadsheet that I have developed so far. I've also got to do the so-called tropic chips as well, and these are the chips that IBM produced for National Semiconductor, basically the same as the earlier Token-Ring chips that IBM itself released. And these have a similar pinout. I have to really find out how these, just really of what the, what if any differences would be. And this is a microchannel adapter. So this would be ultimately a Pine Grove or a Pine Grove shrink level of chip, because it doesn't have the interface chip. It's straight on the microchannel adapter with really not too much support chips to go through and attach to the bus. And I've even got the diskette in there. I need to archive that. So I'll be going through for kind of making a bigger determination there. The let me see what I have, and that's probably going to be a so-called long adapter. Get my keyboard out of the way. Okay. So, like in this instance, we have a spyglass level chip on a microchannel adapter. Again, get that light for the, it actually is where I'm kind of prevented with the, so that's a 50F 1439. We saw that same chip on one of those 8-bit adapters, but it has an interface chip for the microchannel bus that's there that IBM had to include and it's got that, there's the FRU and that 14 code of the plant code of where it came from. And that was needed for interfacing the spyglass chip to the microchannel bus. With the later adapters, in fact, I was even looking to see if that was very similar coding, but so later on with the Pine Grove level, there were no interface, additional interface support chips that were needed. This chip went through the Token-Ring chip, the main Token-Ring chip, went through an interface directly to the microchannel bus. And of course, they use these ASICs on other bus types than microchannel, including the same versions. But there were obviously different ways to go through and work with the buses, the different buses types that they had, and of whether they need support chips and things like that. There could be modes that they would shift on the adapter itself to go through and for what bus type it was attached to. This is actually a very late production IBM chip, and this, what was remarkable about this to me is that this is a 3-COM board, so big in the networking side, but it is rather than the Tropic chipset that IBM had to go licensed to National Semiconductor for doing third-party manufacturers. This is a direct IBM chip. And as we can see, I'm sure people are already reading, this is the 1995 and the 9th week of the year. So this is rather late. And then it is effectively the Tropic ROM version by this coding. This is a different coding than what IBM had for its own microcode. And the same outline that we came to expect from the IBM production of these chips. So, you know, I don't have any real variants of this to see what further angles that that IBM did. Still has the 9352 marking for the plant codes. Maybe if I were able to get more versions of this. And when I've looked on eBay, I've seen other listings for this adapter. They have the Pine Grove Shrink, the other version of Pine Grove Shrink in that position without any changes to the board. And so this is relatively pin, this should be pin compatible. This may be further die shrinks or some other enhanced or improved what they've done with the board, just working with it and making it more efficient or something. And this is what they call the B version of this is the 3-COM 3C629 adapter. And this is the B version. And here is the earlier version of this same. This is a 3C 629. And this has the Tropic chip in it. We can see the different markings there. DP8025 is the Tropic chip that was used on the microchannel bus. And then that IBM production date and even an IBM FRU part number that they had, that 32G 9270, and this is produced in 1992 in the 35th week. And we see some trailing zeros and things like that in that down towards the bottom, whether that's some sort of version or something else. And then it is split into two separate ROM chips for the microcode, as was the IBM standard. When IBM got into started making some of the token-ring adapters for the ISA bus, they went to the 16-bit wide ROM, just as a way to be a little bit more efficient and economical for the adapters. So, yeah, that's the kind of the broad overview. We've seen, in fact, this being a little bit out of sequence. Also, I can show these others. This is the, these are the adapters I was going through and having the continuity meter on, because I'd gone through and I'd pulled those, the chips off of them. And we can see that pin 1 marking here. And it is from the top, you can see that that pin is squared off. All the other ones are circular. That pin right in the corner being pin 1. And on the underside of it, it's also squared off, not circular. And the bevel with the chip in place, the bevel of the chip would have been right along that top edge. So pin 1 being down in this, effectively this lower left corner. This is the adapter I was going through and doing the continuity for the ground, pulling out the Sharpie and marking the pins that I found that were grounded out, you know, were ground level for entering on the spreadsheet. If anybody knows much about networking, and I think I've covered this a little bit before in the past, you know, these ROMs are the microcode. This chip here actually has the MAC address of the adapter, and it's got some other things as well. One's complement of the MAC address and things like that. That's held in that read-only memory of that device. But that's where the MAC address is, and it's a separate part on the adapter. So we have some of the RAM that we've seen with the earlier Token-Ring implementations. That is just 2 chips where it's for effectively the banks of RAM memory that the adapter uses to work with. And the RAM that here on the old version, of course, the initial production of Token-Ring being up here, and all these chips later on being integrated, or mostly integrated with the exception of the microcode ROMs, into that single ASIC that is that so-called silver cap, or bigger version of one of these separate chips that's on the adapter. I haven't really quite decided on which adapter I'm going to sacrifice for this, the 50G 8180 to send to Ken. I've got a few of these adapters around. I really want to see if I can locate more, just so I can pick up enough adapters to replace what I go through and salvage. Before I do it. So I'm not going to pull out the heat gun today, I don't think, and go to work on this. But for all the factor of being late and all, we've had a stream that's been about 40 minutes or so, and that's probably been fine for that. I do thank everybody for attending. I haven't really looked at too much at the chat. There's it seems like everybody's just listening in a little bit to what's going on, and not many chat comments, but that's fine too. For as I go through and kind of do my stilted presentations of things, that's fine for people just watching. I mean, you don't have to participate in that level, but just a little bit indication of what's kind of going on or what I've been working with. I know I haven't got back in the sequence of doing any regular videos. I've just been doing the live streams on the Saturday morning, so I'll get to the point where I'll resume also doing videos. And at what point that'll come in, I don't know. But I'm going to try and do some stuff with the thin client systems, as I've had here in the background, for a separate thing. Thank you, Jesse. I appreciate viewers as well. This is just my world and how I go through and what I focus on and do, and even the minutia of having that clipboard out and that notepad to go through and to see what I can determine of these chips that were produced 30 years ago, and get some sort of pinouts and a little bit of trying to figure out or get a rough schematic and an idea of what the design did. Now, with there may be even some news that will come out really soon, because within this next week, the person that went through and of course having a team at IBM, but going through and doing the Token-Ring prototype, and the board being very similar to the actual production board that this is. He'll be finishing up doing teaching the coursework that he does, and he may be able to go through and provide some insight of really of the what was going on 35 years ago. We just went through of course, the 38th anniversary of Token-Ring being introduced on October 15th of 1985. But I really look forward to those IBM insiders of what a little bit of their memory was of those days of going through and trying to come up with these prototype adapters, and then over time going through and making those more efficient, the design using less chips, smaller adapters, to even have more functionality. And so that may be something that's coming up here real soon, that we can, they'll give a little bit more insight to what is there for that. But I do appreciate everybody tuning in. I will go through and at least see you next week for the live stream. I haven't decided what I'm going to have there. If I get the NetFandy 7000 here in the studio, it's going to be a little bit warmer, but it's also going to be a little bit noisier. That's a quad Pentium Pro unit that I can use on the Token-Ring development side. I can go through and have Token-Ring adapters in there. It's got a PCI bus and ESIA. And so we'll have to see. The noise aspect probably won't be too bad for me, because I have these noise canceling headphones. Being that I have this microphone on the headset too, hopefully that'll cut down on a little bit of the noise that could exist in that circumstance if I have that system fired up, because it is a little bit of a mini wind tunnel, and it is a server room device. It's not designed to be in a bedroom, much less a studio, um, for the noise it makes in just running the cooling fans and things like that. But like I say, I think those Quad Pinion Pros, I want to have that as my electric heater here. And it'll make the space a little bit more warm. I'll probably slip on my coat after I end the stream here, and we'll go through and finally get to eating some breakfast this morning, and going through and drinking more of my coffee. So this is IBM Museum. That's all I have for now. Thank you guys for tuning in. Bye-bye.